Welcome to the review and preview problems from the CCG book, Chapter 8, Problems 93 through Problem 99. Eight 93 says find the area of the shaded region for the regular pentagon below if the length of each side of the pentagon is 10 units. Assume that point C is the center of the pentagon. So looking at my pentagon, my five-sided shape, I can draw triangles within my pentagon. So the shaded region is made up of three of my triangles. I can find the area of my triangle by first finding my central angle, so 360 divided by 5, which gives me 72 degrees. And then when I look at my triangle, I need to create a right triangle, which would give me this angle at the top to be 36 degrees. I know that half of my base of 10 would be 5. I can find the height of my triangle using the side adjacent, which would be the cosine if I had my hypotenuse, but I don't have my hypotenuse, I have my base. So I need opposite and adjacent, which is the tangent of 36 degrees is equal to 5 over A. My inverse operations, I have A times the tangent of 36 equals 5. Divide by the tangent of 36, which gives me a length of 6.88 units. So to find the area of my triangle, my formula is base times height divided by 2. So if I plug in my base of 10, my height that I just found of 6.88, multiply that and divide by 2, 68.8 divided by 2 gives me an area of 34.4 units squared. So it asked for the area of the shaded region. So we want to take that 34.4, multiply it by 3. So the area of our shaded region is 103.2 units squared. 8-94 says for each triangle below, find the value of x if possible. Name the triangle tool that you used. If the triangle cannot exist, explain why. So looking at the triangle below, in letter A, am working with a right triangle. If I use my right triangle trig to find my x, I would take, using 60 degrees, opposite over hypotenuse is the sine. So the sine of 60 degrees is equal to x over 28. Use inverse operations, so 28 times the sine of 60 is equal to 24.25 units. Looking at example B, we have two angle measures, 50 and 68. I know that all of my triangles add up to 180 degrees, so I could find this missing angle, but that doesn't really do me any good. I then can use my law of sines, though. Anytime I'm given two angles and their corresponding sides, I can use the law of sines. So the law of sines states that we take the angles opposite of what we're working with. So if we have 68 degrees, we would take side 7 and put it over the sine of 68. Set that equal to our x, place that over the sine of 50. We can use cross multiplication because that's the inverse of division. And we get that x is approximately 5.78 units. When we look at example C, we have a right triangle. So looking at our right triangle, we could think of the Pythagorean theorem, a squared plus b squared equals c squared. If we plug in one of our legs, so x squared plus 19 squared equals 17 squared, we notice that this leg is bigger than our hypotenuse, which in fact means that there is no solution because the hypotenuse has to be the largest length on our triangle. Looking at letter D, it says the area of the shaded region is 96 units squared. Find x. So we know that our base is 8. So if we look at the area of our shaded region, the area of a triangle is the base times the height divided by 2. So if we plug that information in, 96 is equal to 8 times h divided by 2, and use our inverse functions. The height of our triangle, or our x in this case, would have to be 24 units. (8-95) says find the measure of each interior angle of a regular 30-gon using two different methods. So the first method that comes to mind is if I had a 30-sided shape, I could create 30 little triangles inside, and I could first find the central angle by doing 360 divided by 30. This would give me a central angle of 12 degrees. I then know my entire triangle equals 180, so if I take 180 degrees and subtract 12 degrees out, I know that my interior angles of my 30-gon have to be 168 degrees. So these two angles would make up 168 degrees. This angle corresponds to this other half of the angle, which would create my entire interior angle of my polygon, so 168 degrees. The other way I can find the interior angle of a polygon is by looking at my exterior angles. I know the exterior angles always equal 360 degrees no matter how many sides my polygon has. So I can take 360 degrees, divide that by 30, and I know that my shape has an exterior angle of 12 degrees. I then know that these form a straight line, so my interior angle and my exterior angle. So I can take 180, subtract 12 from that, and I get my interior angle is also 168 degrees. 8-96, examine the diagram below. Assume that line segment AD and BE are line segments, and that BC is congruent to DC, and AE, or angle A, is congruent to angle E. Prove that AB is congruent to ED. Use the form of proof that you prefer. So they told us that line segment BC is congruent to line segment DC. So I'm going to put that under my statement column. And my reason for that, or my justification, is because it was given. I also know that angle A is congruent to angle E, and that was also given. I then, looking at these two angles, know that they're vertical angles. So I can say that angle BCA is congruent to angle DCE. After that, because of angle-angle side congruency, I can prove that triangle ACB is congruent to triangle ECD. Therefore, I can conclude that AB is congruent to ED, because if I prove congruent triangles, it implies that all of their parts are congruent as well. 8-97, for each diagram below, write and solve an equation to find x. Looking at A, I am looking at a 5-sided shape, which is a pentagon. I can find out the interior angle sum by taking, there's 3 triangles inside of it, so 3 times 180 would give me this, which equals 540 degrees. I can then set all of those angles, 2x plus 250 plus 90 equal to 540, which, using my inverse operations and subtracting my 250 and my 90, gives me 200 on my right. Divide by 2, and I get x is equal to 100 degrees. Looking at B, I know that these two lines are parallel, so I know that this angle corresponds to this angle, which is 2x plus 30. I then know that these two angles are vertical angles. Vertical angles are equal, so I can set 6x plus 18 equal to 2x plus 30. Use my inverse operations, so I get 4x is equal to 12. Divide by 4, and I get x is equal to 3 degrees. Be really careful that if they ask you to solve for a specific angle other than x, that you would plug it back in. 8-98, on graph paper, plot the points A, which is at -3, -1, so you can see it's plotted here. B is at 611. A says find the midpoint between A and B. So looking for the midpoint, you can see the midpoint is at 3, 5. A way to find the midpoint is you can add your x, so -3 plus 6, divide by 2, and you get 3. You can then do -1 plus 11, divide by 2, and that's how you can get your 5. Find the point P on AB that is 2/3 of the way from A to B. So 2/3 of the way from A to B be really careful up here. -3 plus 6 divided by 2 is not 3. it's 1.5. So we have 1.5, comma 5. Sorry about that. Find the equation of the line that passes through points A and B. So when we write the equation of a line, it needs to be in y equals mx plus b form. We can tell by looking at our line that our y-intercept is 3, so y equals positive 3. Our slope to go from one point to another on our line is rising 4, running 3. So up 4, right 3. So our slope is 4/3, and we just wrote the equation of our line. Find the distance between points M and P. So the distance from point M to point P, this distance right here is 1.5. This distance right here is 2. So we could use the Pythagorean theorem. 2 squared plus 1.5 squared equals c squared, which would give us the square root of 6.25, which is approximately 2.5 units. So what fraction of the circle below is shaded? If this angle is 60 degrees, we know an entire circle is 360. So if we subtract that unshaded region out, we get 300. So we want the shaded, so we take 300 over 360, and we can say that B is the correct choice.